All right, let's talk about probability and statistics. If you're watching this video, you'll need the probability PowerPoint and the statistics. I may do this in 2 videos, not sure. You also need your statistics and probability notes, printed notes. Make sure to print those double-sided, and you should have those in front of you with your pen or pencil and your calculator. Remember, the goal of these videos is not for you to keep up. That's what the pause button is for. I'm probably going to talk faster than you can keep up as far as doing your math. So pause as you need to. You'll be filling in some things as we go along and following along with the PowerPoint and me. Here we go. Probability. We are talking about the likelihood that a given event will occur, rolling a dice, picking a certain card or drawing a certain card, or the probability of the weather. Main one we're going to focus on is theoretical probability, like coin toss, or uses known elements. We're going to talk about coin tosses. We're also going to talk about rolling dice. Let's see. So let's talk, speaking of coin toss, this is like an actual event. Probability of tossing, let's say if you look at your worksheet, probability of tossing a coin 50 times and it landing heads up 27 times. We can report that several different ways: a fraction, a percentage, or a decimal, or even odds. And your first equation on your study guide should look like this. F of x, or my frequency of outcome x, is equal to the number of events with outcome x, so like I said, 27 times, and n is our total number of events, or the total number of times I flipped it. So go ahead and write that simple one out. 50 coin tosses, 27. Go ahead and find out your frequency. All right, once you've done that, let's talk about... Sorry, got interrupted. Sorry if I'm repeating myself here. So what we just did were actual events, relative frequency, actual events. You should circle or underline that on your notes. Now let's do, this is, so probability is a little different. It's just something that hasn't happened. I don't need to toss a coin to realize the percentage or the prediction of that event. 50% of the time I'm going to get heads, 50% of the time I'm going to get tails. So my f of x, I'm going to toss it. I'm going to toss it one time, and there's 2 possible outcomes, right? Heads or tails. Let's see, no work that you need to do on that one on your worksheet other than underline or circle hasn't happened. All right, let's keep moving. Same idea. So what is the probability of tossing a coin twice and it landing heads up both times? I tossed it twice. What's the probability of it landing heads up both times? So if we think about that for a minute, my desirable outcome is landing heads up. That's my desirable outcome. How many possible outcomes? Well, there's 4. You think about it. I toss a coin, I'm going to get heads or tails. This heads. If I toss it, heads or tails. So that would mean heads, heads right here, or heads and then tails, which is going to be 1 over 4, or 0.25, or 25% of the time. And again, that's not something I have to do. That's what we mean by theoretical probability. It has not happened. Let's see. Same idea. So you can see this gets complicated pretty quickly. Let's read through this. What's the probability of tossing a coin 3 times? That's my desirable outcome. And having it land heads up exactly 2 times. So there's 8 possible outcomes. My point is, this is going to start to get a little complicated. You can't quite pull that, see 8, you can't just pull that number out without doing a probability tree, which is fine. But imagine if, see, this has pretty low numbers, 3 times, having it land up, heads up 2 times. What if this was like tossing it 15 times, landing heads up exactly 5? It gets complicated quickly. So I'm going to show you a different way to get the same number. Let's scroll down. And that is the Bernoulli process. That's on your worksheet. It looks like an ugly equation, and I think I even wrote that on your worksheet. It really looks ugly, and it's not. So let's just read through the variables. P is probability. X, number of times a specific outcome will occur. N is our number of trials. P is a probability of success. Q is probability of failure. And this exclamation point is called factorial. Product of all integers less than or equal. So let me go through, let's go through, here we go. And I'd like you to write this out, follow along with me, write it out to the right. There's some blank space on your worksheet, and fill in all the numbers. All right, here we go. So N, let me just underline something, here we go. So N, we toss that coin 3 times, N factorial. So it's the N factorial is the product of everything, or all numbers below that number. So if it's 3 factorial, 3 times 2 times 1. That's it, simple as that. Times, and your parentheses are going to be important for order of operations. P, remember P is probability of success. What's the probability of getting heads or tails on a coin toss? It's 0.5. Raised to the X. X is number of times the outcome will occur. That's our outcome that we want. If you reread the question, probability of tossing a coin 3 times, landing heads up twice. Okay. And then times 0.5, that is Q, and Q is failure. So failure would be getting tails. I also have a 0.5 probability of getting that. And then notice in your equation it says N minus X. Well, remember, N was 3, and then our X was 2. 3 minus 2 is 1. Denominator is pretty straightforward too. X factorial, so 2 times 1. And then N minus X, 3 minus 2 is 1. And then factorial is 1. So that's pretty straightforward. Order of operations, make sure you do your exponents, then your multiplication across the numerator, and then your denominator. And again, it looks ugly, and I know that this is more straightforward, but you'd also have to draw out this whole probability tree. Up to you, but you will see some quiz questions on Bernoulli's process. All right, so let's talk about and, or, and not. Here we go. And. So these are independent events occurring simultaneously. What I want you to, I know I have it in bold on your worksheet, like this, but it's really important that you understand it has to do with and, or not. Here's what I mean by that. Independent events occurring simultaneously, the product of individual probabilities. Let's see if they go into an example. Sure. What is the probability of rolling a 4 on a single die? Okay, so what's the probability of rolling anything on a 6-sided die? 1 over 6. So yeah, probability of 4 is 1 over 6. The probability of rolling a 1 is 1 over 6. What's the probability of rolling a 4 and then a 1 in sequential rolls? So these are events occurring simultaneously. You have 2 dice in your hand, you roll it. What's the probability of you rolling a 4 on one of them and a 1 on the other? We're going to multiply those probabilities. So 1 over 6 times 1 over 6, or 1 over 36, or 2.78% of the time that's going to happen. Make sure you show your work on that one, and then we'll move on to the and. We'll move on to the or. So this one's a little different. These are mutually exclusive events happening. Again, the word or is really important. And these are events occurring individually, like probability for dice is still the same. What is the probability of rolling a 4 or a 1 on a single dice? Or look at your worksheet. What's the probability of rolling a 4 or a 1 on a single die? That's the same thing. But what if you took a 4, or what if you rolled 1 dice, got a 4, picked it up, rolled it again, and got a 1. So that's what we mean by independent events occurring individually. That's where you are adding the probabilities together. That's the only difference, adding or multiplying. So it's really about reading that question. Rolling a 4 or a 1 on a single die, that's your kind of trigger, or that's your hint that you're going to add. Rolling a 4 and then a 1 on 2 dice, that's your hint to multiply. Okay, probability. What's the probability of an event not occurring? So that's just 1 minus the probability. What's the probability of not rolling a 1? Well, it's just 1 minus the probability of rolling anything, which is 5, 6, or 83% of the time. And let's see, yep, show your work on that not one. That's pretty straightforward. And then we're going to move on to cards. Alright, cards. Let's see here. First thing you'll need to write down, let's make sure we're all on the same page about cards. 52 in a deck. Aces are 4. Face cards are 12. Tens are also 4. Go ahead and write that down in your worksheet. What's the probability that first card is an ace? First card is an ace, so there's 4 aces. 4 aces. That's pretty straightforward. And you're doing this, I showed the answers on all of them, but you're showing your work on all of these. So 4 over 52, that's just, they're just showing that it's reduced. So I could say 0.0769 or 7.69% of the time. So read this one carefully. Since the first card was not a face, what's the probability that the second card is a face? Okay, so 12, because we have 12 face cards, but look, one of them is gone, so 12 over 51. Again, make sure you're showing your work. First card was not a 10, what is the probability that the second card is a 10? 4 10s in a deck, and we're subtracting 1 card because it's gone. Okay, so 2 cards are dealt from a shuffled deck. What is the probability that the first card is an ace and the second card is a face card, or ding 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 ding, a 10? Remember the or? So look at your equation. Probability of ace, probability of a face card, probability of a 10. Okay. So 1 over 13, and they're using these reduced numbers. Don't get confuzzled about that. So look, 1 over 13, 4 over 17. So 1 over 13 for ace. They're using the reduced. 4 over 17 for face card. But here's what's important. Plus, 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 plus. Why? Reread the question. What is the probability that the first card dealt is an ace and the second card, these are independent events, right? That's why we're adding. These are independent events. Or a 10. So they added those together, do some math. That's how we end up with 2.41. Please make sure you're showing your work so you're understanding this, and see if you have any questions for me later. Okay, we're going to do one more. Let's see. Oh, it's on the same. Here we go. It's on the same one. If the first card is an ace, what is the probability that the second card is a face card or a 10? I'll let you do that one on your own. Again, your answer's there. Make sure you're showing your work. And then we're going to move on to conditional probability. All right, Bayes' theorem. Last one that we're going to do on probability, and then we'll switch gears and talk statistics, which is a little easier. This is a weird little equation, and I actually just want to read through this scenario first. So scan through that, and I'll talk you through it. So we have this cell phone company, right? And they make their screens with 3 different vendors, A, B, and C. A makes 60% of the screens, B makes 30%, and C makes 10% of all these screens for these phones, right? So they do quality control when they're made, and they know that A, 0.7% of them are defective. 1.4% of vendor B are defective, and C 1.9 are defective. Okay, so here's the question. If I'm randomly grabbing a phone from a store, right, what's the probability that it was defective and produced by vendor A? I know how many from A are defective, I know how many from B and C are defective. I'm randomly grabbing it, it's broken. How do I know it's from A? This is kind of some cool math. So, digest that question, reread it if you need to. And let's do, okay, here's what this is saying. It's asking for probability of A, and this little line means given. Given that it's defective. What's the probability the phone came from A given that it's defective? Meaning, remember I grabbed it and it's defective? So then let's read through the variables. They're pretty straightforward. Notice this first one, it is reversed. So probability, it was from A given that it's defective. What's the probability that it was defective given it's from A? Don't we know that? We do know that. Probability that it's defective given it's from A. We do know that. That is 0.60. So this number is going to be 0.60. I'll walk you through part of it. And then times, don't we know the probability that the phone came from A? We sure do. Probability, excuse me, I read that wrong. It's 0.007, probability that it was defective from A, and then 0.60 are the probability of the ones that came from A. And let me scroll down. So this is just kind of saying what we already know. Probability they came from A, B, and C. Probability of the defective ones from A, defective ones from B, defective ones from C. Don't forget to change your percentage to decimals, always. Here we go. Here we go. How many are from A? 0.60. How many were defective from A? We know that. And then the denominator, notice it's the same thing. Let me just scroll back to, yeah, C, probability of A, probability it's defective given is from A, same thing here. And then we just go down the line, plus your information for B, well, with multiplying in between, and then plus all your information for C. So we'll go back here. 30% came from C. Excuse me, B. 30% came from B. 1.4 of them were defective. Plus 10%, or 0.10, came from C. Times 1.9 of them, or 0.019, were defective from C. That's it. So it looks a little goofy, but you just have to understand where what the variables mean, and then it's pretty straightforward. Make sure you're showing your work, and you should get, looks like about 40%. So that's pretty cool. When I grab a phone from the shelf and it's defective, what's the probability that it came from A? And if I were to read that here, what's the probability it came from A given that it is defective? Okay, I think I'll stop that video, and then I'm going to do a different one for statistics. I'll meet you over there in just a bit.